Hello, guys. Good evening. Okay, so we'll continue with handout 6, which is looking at local area networks, technologies, as well as network topologies. In handout 6, we'll look at what a local area network is, what a topology is, as well as the various topologies that are there. We'll look at the advantages, their disadvantages, as well as other LAN technologies that are there. Okay, so a local area network is basically a computer network within a small geographical area, such as a home, a school, a computer laboratory, office building, or group of buildings. A local area network is comprised of interconnected workstations as well as personal computers, which are each capable of accessing and sharing data and devices such as printers, scanners, and data storage devices anywhere on a local area network. So a local area network, like I've defined, an example again give you is our university, Copperbelt University. It is a local area network. Why? Because it's found in a small geographical area. And examples of these geographical areas, one of them is a school which we belong to, office building, or a group of buildings within a small geographical area. So Copperbelt University actually qualifies to be a local area network. We'll look at wide area networks as well as metropolitan area networks later on, but for now, we'll just focus on what local area networks are. We also need to know and understand what a network topology is. A network topology refers to the physical or logical layout of a network. This defines the way nodes are placed or interconnected with each other. By nodes, we are looking at things like computers, laptops, desktop computers, routers, switches that are used along the communication path. So the way these devices are connected is what we call a network topology. And a network topology can be laid out as a physical layout or a logical layout. So a network topology refers to the physical layout of a network as well as the logical layout of a network. There are two types of network topologies, like I've indicated. One is physical. By physical, it means things that you can see, things that you can touch. You can touch a cable, so you can see the physical layout of a network. Logical things are things that you can see. If it was in the biblical ways, we can say spiritual things. So logical things, we are looking at how the data moves within that cable. You're not able to see how the data moves in a cable. Why? Because that's just logically how it is. It's spiritual, if I may say. Okay. We also are going to look at direct point-to-point communication. Direct point-to-point communication. Basically, we are saying communication between two devices, which is direct. So you have computer A, you have computer B. For them to communicate, there is this medium they are using. There is no like agents in between. There are no other devices that are placed in between, but just one cable joining computer A or computer B. Or in a scenario where you're looking at wireless, just like an example I would give would be Bluetooth. You have this laptop, you have this phone. The way you pair them is just that one connection between this device and this device, direct point-to-point connection. Early networks used dedicated links between each computer. So each pair of computers were connected, and basically you are looking at a number of a maximum of two computers. Why? Because each computer comes with just one network interface card. Okay, so but if you intend to expand, then you have to add more network interface cards to a computer. So this particular scheme has advantages as well as disadvantages. Okay, each connection is independent and therefore appropriate hardware can be used. Secondly, the connected computers can decide exactly how to send data across a connection because there are no intermediate devices between the sender and the receiver. Again, it is easy to enforce security because there are only two devices involved, two computers, computer A and computer B. So you may find that it's actually the same person that is managing computer A as well as computer B. And then since there is this cable that is being used, it's possible you can manage it without having a third party intrude. But as well, we are saying this scheme has what we refer to as disadvantages. Why? How many more hosts can communicate with one computer? So if I have this computer and there are other computers as well, then it means from this computer to the other computers, if I'm connected to 3 computers, I need 3 more cables. Okay? One going to this other computer, one to the other computer, one to the other computer. The other thing is, the more computers that I join into this network, the more connections I have. Remember, with one computer, I only have one cable. If I have to add 2 more computers, I have to add 2 more cables. So with the number of computers that we add, the more the cables that will be used. This particular setup is very good for long distance communication. For example, if let's say Zamrain or any ISP that you know, let's say iConnect, they have an office in Ndola, they have an office in Kitwe. Between iConnect, Kitwe and Ndola, they can use just one line to connect the two. So they can connect the end device, the device that is on the front end of the Ndola office and the device that is on the front end of the Kitwe office through this one cable. They don't need a number of cables to connect. So in such a setup, direct point-to-point communication is vital. Sorry, guys. Okay. So like I explained, if there are just 2 computers, you just get to use one cable. If there are 3 computers, there will be need of a cable to each of the other computers. So the more the number of computers, the more the number of connections that you get to do. Okay, so let's move on. Direct point-to-point, basically, you are connecting 2 devices, but in local area networks, the approach that is applied is what we refer to as shared communication channels. So local area networks rely on sharing a network. Each LAN consists of a single shared medium, which is usually a cable, to which main computers are attached. They take turns using the medium to send packets. Several LAN devices have emerged from researchers. The designs differ in details such as voltage, modulation, etc., but they all center on sharing of the medium. Sharing has become very important because it is economic and it helps to reduce the costs. Instead of you having 5 cables coming out of your computer, just one computer is used and you're able to share that medium to communicate with other computers on a local area network. Imagine if it was direct point-to-point communication. From my machine, if I have to communicate on the CBU local area network, which has more than 500 computers, I'll need 500 cables being connected to my machine. That will be a whole lot of mess for cabling just within the institution. Okay? Can you use point-to-point in a LAN? I've just given an example. That will be a lot of cables. So point-to-point cannot be appropriate in a local area network. You can read more on that, and you should be able to get why that won't be appropriate. Okay. There's a term we refer to as significance of LANs and locality of references. One of the reasons why local area network is economic, since LAN technologies are both inexpensive and widely available. The main reason for demand for LANs is the speed. it can be attributed to what we refer to as locality of reference principle. In this principle, or this principle explains that communication among a set of computers is not random. Instead, it follows these two patterns. One, we are saying, first, if a pair of hosts communicate once, it is likely that again in the future, they are likely to communicate. This is what we refer to as temporal locality of reference, to imply a relationship over time. If I've communicated to this computer before, there is a possibility I may communicate to this computer before. This is what we refer to as temporal locality of reference. Second, a computer tends to communicate more often with other computers that are nearby. This is what we refer to as physical or spatial locality of reference. Okay, you can just read more on that, but you don't expect much questions from there. Okay, learn topologies. We were saying topologies come in two, physical as well as logical. Because many learned technologies have been invented, it is important to know how specific technologies are similar and how they differ. Each network is classified into categories according to the topology or general shape. So these topologies at most, they are classified based on the shape they form. Okay. One of the topologies that we'll look at is what is called a star topology. If you can look at that diagram there, the boxes there are computers. The blue lines there are cables. Okay, so they are connected by what is called a hub. We'll look at what a hub is in the next handouts. So a star network, for this computer to communicate to this computer, it has to communicate first through the hub, and then the hub communicates to the other computer. If this computer wants to communicate to this computer, it has to communicate first to a hub, and then the message is sent to the other computer. So a star network uses a star topology if computers are attached to a central point, and this is a central point that we are looking at, which is a hub. Hubs are used to connect computers together. A hub is basically an electronic device that accepts data from a sending computer, let's say this one, and delivers it to to all connected computers. So when this machine sends something, whatever will be received will be sent to all the other machines on the network, but only the machine which the data is intended for will get to receive. But data will be sent to actually all the computers, but only the receiver will open the message. Okay, so this is what this figure illustrates here. Okay, we also have what we call a ring topology. Basically, we are looking at the shape. So if you've looked at this shape, the shape forms more like what forms like a star. So for a ring topology, we are basically looking at something which is in a shape of a ring. So computers are connected to each other through a cable, and they form a ring. Okay. So a network that uses a ring topology arranges the computers to be connected in a closed loop, a round thing. A cable connects the first computer to a second computer, another cable connects the second computer, the third computer, and so on and so forth, until all the computers are connected back to the first computer. Computers are arranged in a circle as shown in the figure below, the one that I just showed you. Ring refers to the logical connection among computers, not the physical orientation. Computers in a ring need to be arranged in a circle. Need not to be arranged in a circle. it's possible these computers can actually be arranged in a square, but we are looking at the logical way the data is sent. So we're not looking at the physical way the computers are, because they may not really be in a ring, but the logical way how the data is sent. The third topology that we have is called the bus topology. So a bus topology, we have one shared cable, and then each computer connects to this shared cable. So when something is sent over the cable, it will be sent to all the computers on the bus network. So a network that uses a bus usually consists of a single long cable to which computers are attached. The ends of a cable, the ends of a bus network must be terminated to prevent electrical signals from reflecting back along the wire. So these ends, they must be terminated to avoid signals from reflecting back along the wire. Any computer can send a signal down the cable and the computer receive the signal. This figure below here illustrates the bus topology. All computers attached to a cable can send signals, and any computer can send data to any other computer. The computers attached to a bus network must coordinate to ensure that only one computer is sending a signal at a time. So if this computer is sending data, these are expected not to send data until this computer sends. So there is that coordination that happens as these are sending the data. Otherwise, if they don't do so, there will be some chaos as the results are being received. Why do we need multiple topologies? Why don't we just have the star topology and we forget? Why do we have the bus, the ring, as well as star topology? Why is because each topology has its own disadvantages as well as advantages. So based on which you like most, the disadvantages of this one or advantages of this one may make you actually want to use this topology from the other. If we look at a ring topology, it has the following advantages. It makes it easy for computers to coordinate, access, and detect whether the network is operating correctly. 2, transmitting network is not affected by high traffic or by adding more nodes, as only one node having token can transmit. So let me just go back. In a ring topology, there is a token that is given to a machine to send. So if that token is given, let's say to this machine, it's only this machine that can send at that instance. The other machines will have to wait until this machine finishes sending, and then the token is passed on to the other. So that's a very good advantage, as there won't be any congestion on the network. Last but not the least, it is cheap to install as well as to expand. Well, we also have disadvantages. One disadvantage is that an entire ring network can be disabled if one of the cables is cut. If you look back, these are connected, and then the traffic goes in only one direction. It doesn't go in both directions. So if there's a cut here, and then this machine is trying to communicate to this machine, it will communicate to this machine, but it won't be passed on. Since there's a break here, this message won't be passed on to this message, and that's how the network dies, because communication only moves in one direction. So that's a very major disadvantage. If there's a break or if one of the computers dies here, then there will be challenges to send data. Adding or deleting the computer disturbs the network. We've already looked at this. If one node goes down, then it will be a bit tricky to send to the others. A star topology. The advantages of a star topology. The advantages of a star topology are that there is fast performance with few nodes and low network traffic. The hub can be upgraded easily. So it's possible to upgrade the hub, the one that is in the middle of a star topology. It's also easy to troubleshoot. It's easy to set up and modify. only that node which is affected and has failed will not communicate with the network, but the others will be able to communicate with the network. If I go back to the diagram for a star topology, this is what we are looking at. If, let's say, this cable gets damaged and this machine wants to communicate with this machine, it will still communicate with this machine because there is still this central hub that is making them connected. But if this central hub had to die, it means the network as well in this setup dies. So that's a disadvantage. If this central point, which is a hub, has a failure, then the whole network collapses. But as well, if this cable gets to be cut or this machine is malfunctioning, the whole network doesn't get affected. So I've just highlighted on some of the advantages as well as disadvantages of a star network. Okay. Advantages of a bus network or a bus topology. It requires fewer wires than a star. It is cost effective. Cable required is least compared to other network topologies. It's used in small networks. It's easy to understand. It's easy to expand, joining two cables together, but it also has disadvantages. Same as ring, since a network is disabled, if a main cable is accidentally cut, the network gets to be shut down. If we go back here, let me just go back to the diagram. So if this cable gets to be cut, which means the network will be split in two. This can communicate, this can communicate. So just the cut of the main cable there gets to disturb the entire network. LAN technologies. Okay, so what I'll do for now is let's break. I'll do this as the first part we've looked at is video 1. I'll as well do video 2 for this handout. So for now, let's pause here. We'll come and continue on LAN technologies.